How are you doing, Kirk? Haines is going to come up and talk a little bit about dynamic programming with Crystal. This should be a pretty interesting talk. I've talked with Kirk a few times on and off about some projects he's had. I'm very excited to see what he's been working on and also what he has to share. This is a pretty interesting topic in Crystal. Kirk, are you prepared?
All right. Hopefully, on my screen it's full. So,
Okay.
so I'm going to talk to you today a little bit about dynamic and metaprogramming with Crystal, and kind of the relationship between those two terms, and kind of just sort of lead into some of the things that are possible with Crystal. So, you've seen my name. I'm Kirk Haines. I am currently working as a principal developer relations engineer with New Relic, which basically means that I spend my day really making lots of content and things like that. A shocking amount of it is actually about Crystal. And I've written a whole bunch of articles. So if you want to go to therelicans.com at some point and take a look, I've written a whole bunch of articles about Crystal, some of which might look a little bit like some of the things I'm going to show you here today. So just to kind of dive right in, let's define some terms. The first one is dynamic and dynamic programming. What do I mean by that? And the problem with that word dynamic is that it's really heavily overloaded. It means a lot of different things. And if you go and you Google it, you're going to find a lot of different definitions that sometimes don't have anything to do with what I'm actually talking about at all. So one of the first ones you might find is dynamic programming, where the Wikipedia article says it refers to simplifying a complicated problem by breaking it down into simpler subproblems in a recursive manner. And like an example of this would be calculating a Fibonacci sequence. Calculating a Fibonacci sequence can be broken down into very simple little pieces. But that's not what we're talking about here. Now, something that's a little bit closer to what we're talking about is the Wikipedia definition of a dynamic programming language, a class of high-level programming languages which at runtime execute many common programming behaviors that static programming languages perform during compilation. Some features of which are object alteration, reflection, and macros. And this is in the ballpark, but Crystal is a compiled statically typed language. It doesn't change these things at runtime, and it isn't a dynamic language in the sense of what that Wikipedia article states. So I guess we're all done. Time for the next talk. But not really. Crystal has a lot of very powerful metaprogramming capabilities. And metaprogramming is, again, you go to Wikipedia and look at the definition, a technique where code is treated as data. And a quote from that same article is, metaprogramming can also be used to move computations from runtime to compile time to generate code using compile time computations and to enable self-modifying code. And that's a lot closer to what we're talking about here. What Crystal does is gives a whole bunch of tools that let
Kirk,
us
you
do a
are
lot of very
lagging a little
dynamic
bit.
things. All the code that we have, wrap the code we have, all the magic of the code we have. But I had to go and change this slide earlier because if you were watching when the talk about interpreted crystal was done earlier by Astrite, that whole interpreted crystal thing is really interesting because that potentially opens up the possibility that maybe there could be some sort of eval-like functionality in the language at some point. But right now, Crystal doesn't support eval. Crystal does have mixed-ins and reopenable classes. And what we mean by that is that you can take code that you've written or that somebody else has written and you can reopen that code, you can add to that code, you can change that code, and you can take modules that are defined either by yourself or somebody else, and you can mix them into that code and get new capabilities. Crystal also has reflection, and reflection in this context refers to the ability for your code to know things about the code. So you can write code that looks at the types of things, and you can write code that iterates over the methods that you have defined in classes, or lists out classes or ancestors to an object, all kinds of things like that you can do with Crystal. It's got these reflection capabilities. And Crystal has macros. And macros, just sort of at a high level, are, and we're going to go a lot into macros here in a minute, but macros are code that writes other code, essentially, is what they are. So I want to do a quick compare and contrast between Ruby and Crystal, just to sort of set some groundwork, because I think a lot of the audience is probably pretty familiar with Ruby, both given the audience of who Crystal users tend to be, and the fact that Ruby is kind of Crystal's closest ancestor, closest neighbor language. So Ruby's dynamically typed. Now there's an asterisk next to that because as of Ruby 3, there's bolt-on static type checking in Ruby, but fundamentally it's dynamically typed. Ruby has eval. What that means, there's several kinds of eval, but fundamentally what that means is that with Ruby, you can go take some code and you can feed that code into an eval statement, and Ruby will run it and treat that just the same as the rest of the code in your program. Ruby has define method and remove method as methods that can be used to, just as the names describe, create new methods or delete methods out of your code, and do that at runtime. Ruby has include and extend. Both of these are capabilities that deal with mix-ins, and what they do quite literally is that they mix code from some other module into a different class. Include and extend, the difference is whether they're included as instance methods or class methods. Ruby also has something called refinements, which is basically when you go and you use a mix-in, you use something like that to monkey patch or change some code. Normally that scope is global. It changes that class for the entire program. But refinements basically allow you to scope your changes. So you can scope a change just to the local class, and some other portion of the program using that same class won't have the same changes. Ruby also has send, and send is a big one. Send is a method that is used to call other methods. And so when you use a send statement in Ruby, you can give it a method name and some list of arguments, and it'll go call that method name with those arguments. And this is used a lot in Ruby metaprogramming. Rails leverages it a ton. Some testing frameworks leverage it as a way to dispatch method calls to the right methods when it's running tests and things like that. It's a really powerful thing, and Ruby has it. Now, Ruby also has something called method missing, which is a method that if it's defined, it will get called if you try and invoke some method that doesn't exist. The execution path will go to method missing, and then you can have logic in method missing that either handles that call directly or maybe defines new methods based upon that call, things like that. So all of those things are things that are in the Ruby toolkit for dynamic programming and metaprogramming. Crystal's a little different. Sorry about that, I bumped my microphone. Crystal's statically typed. And on top of that, Crystal does have include and extend, just like Ruby does. There is some commonality there. It has that capability along with Ruby. Crystal also has a form of method missing. Now, it doesn't operate at runtime, it operates at compile time. Method missing is actually a macro hook. If you have a macro defined in your class called method missing, it will get invoked if a method is missing, and then it can do stuff based upon whatever information you give it, if a method that you try to call isn't there. Now, the big one though, whereas Crystal doesn't have all that other stuff that I just listed for Ruby, Crystal has macros. And with macros, you can do all kinds of things that are really cool, including build dynamic things like send, something that Crystal doesn't have, but you can build it. So Chris Seaton, who is one of the main developers on Truffle Ruby, which is one of the alternative Ruby implementations, wrote this in his doctoral dissertation. He said, metaprogramming can also be described as a dynamic language feature. And I thought that was a really interesting quote, because Crystal has really powerful metaprogramming capabilities, but it's definitely not a dynamic language. Yet those metaprogramming capabilities allow you to build those dynamic things in an otherwise not dynamic language. It's kind of an interesting combination there, and kind of an interesting crossing of divides. So yeah, Crystal has powerful metaprogramming features. I probably could do without that slide. So I want to just dive in now with a little bit of code. Talking about dynamic stuff. I've got a little snippet of code here that is just a tiny little application that just prints hello world in response to a web request to a /hello URL. And if you run it, you'll get something like this. And when you make requests to it in the log, at the standard logging, it'll say, okay, that took 56 microseconds. That took 39 microseconds. There's some information there, but there isn't a lot of information there. And is Kamal lying to us? Did it really take 39 microseconds to handle that request? We'd like to find out, and we'd like to find out without having to rewrite our app or rewrite Kamal. Neither one sounds too pleasant. We can. If you include, in this, I took that little piece of code and I included one other library in it. And I didn't change it in any other way other than to require APM. And then I run it again. And voila, we have a bunch more information. We find out that while Kamal still says, yeah, it took 72 microseconds or 41 microseconds to handle /hello, there's a little bit more detail there. The time to run the inner request handler and flush the IO response was 159 microseconds, and the total response time from beginning to end was 783. Some interesting details there that we're getting out of our running application without having to change anything about our application and without having to go write our own private version of Kamal or anything. So how did this work? So basically, in a nutshell, I have these two little snippets of code where I reopened a couple of methods and wrapped them. And the sort of magic in all of this is that previous def statement. The previous def that you can see in the middle of each of those methods. The code above and below are used to generate our timings. And then what previous def does is it just calls the previous definition of that method. And this is a really powerful thing wrapped up in something that's very, very simple. It's kind of like Ruby's alias method. It lets you access, if you overwrite some method with your own method, you can still access that old method by calling previous def. And that enables you to do things like this, where we're wrapping somebody else's code in our own code in order to do new and useful things without changing any of their code. Their code isn't changed. We're just wrapping it in our code and then calling it. And it's all through the power of previous def. Just one little tiny piece of Crystal's toolkit for all of this sort of thing. So let's come back to send, because I mentioned it earlier, and it's kind of a big one. I've seen, in the forums, sometimes people come in and they want to know, how in Crystal you can do some sort of dynamic dispatch, how you can call a method based upon a command line input, or based upon, input that comes from a config file or something like that. And the short answer is you can't. But the longer answer is that you can, kind of. You just have to build some stuff around it. And Ruby uses send in a lot of metaprogramming stuff. Like I mentioned, it's used all over the place. And I'm going to kind of skip over some of this detail because I'm talking too much and showing too few slides. I wrote a send implementation for Crystal, and the drive to do it was a problem that I ran into. I have some software that I've been working on where it can take a pretty complicated set of YAML configuration files. And Crystal's YAML serializable stuff does a brilliant job of parsing this arbitrarily complex YAML data into a beautiful little class structure where I can call some methods and I can get some information out of it, and I can, it's wonderful. But I wanted to be able to, from the command line, pass in something like this, -k foobar, -k deeper nested key value, something like that, and set those values in my configuration object that gets generated from YAML serializable. And it turns out it's pretty hard to do that, because if you have an arbitrarily complex structure where you can't really predict what you're going to have, that makes it hard to write declarative code to call the specific methods you need to call. But this little snippet of code here is basically all I needed in order to make this work. Once I had a working send implementation, then all I have to do is walk through my little structure of keys and a value, and I can go set that information in the config object. If that method is there, it will get called and it will get set. And so how did this get built? What did we need to do to build this? So the first thing you need is you need a way to wrap a method call in something that can be stored in a data structure. Oops, too many slides. Crystal gives you two ways to do this. And then basically, Crystal gives you two ways to do this. The first is with procs, and it's pretty straightforward. With a proc, you can have a block that calls a method. And a proc is something that you can also store. You can store it in a variable, you can store it in a hash, you can store it in a name tuple. You can store a proc. And so a proc gives you a way that you can encapsulate a call to a method in something that can be stored. And then the other thing that you can do is you can use a record. Now, record is itself a macro, and what it does essentially is it creates a struct with a given name and some set of instance variables. And then if you want to define methods on that struct, you can declare them in your record declaration like this. And you can use a record for a encapsulation of a method call too, because what you can do is you can use a instance variable for each of the arguments to the method call. And then you just define a method like call on your record that calls your other method with your arguments. And then all you do is, create a new instance of that struct and pass in whatever your arguments are, and then call.call, and bang, you've got an entity that, again, you can store, you can pass around, you can do anything like that, and invoke your methods. So in addition to that, you need lookup tables. And basically, you need some way of, given a method name And really, it's a method name and a type signature for the method. You can go look up what you're supposed to call. And that is really as simple as some hashes that you have stuffed into a constant or something like that. In this case, we have hashes stuffed into constants where the constants are named according to the method type signatures. And then the other thing you need is you need overloaded send methods that can be used to call your methods to send your messages out according to a given type signature. And it just looks something like this. And if you put all of that together, it's going to look like what I'm going to show you in a minute. So we have just this sample test class here. It just defines a bunch of sort of meaningless methods. And then if you were to implement this by hand, you could build something like this. Now I use procs instead of records here just because it's more concise to type it, but records are actually the better choice here because in performance testing this stuff, if you use records and you compile in release mode, it is very nearly as fast as a direct method call to use send. The difference is less than, it's infinitesimally less. It's like the difference between 380 million method calls a second and 378 million method calls a second. I mean, it's a minute difference. Whereas if you use procs, the margin is wider. But this is basically how you would implement this by hand. Now, the thing is that implementing this by hand, if you have a big class or you have a lot of classes, is going to be a pain. And the cool thing, though, is that Crystal has macros, and macros have type reflection. And type reflection lets Crystal build all of this stuff for you. Crystal can look into your code. Crystal can see all of your methods. And Crystal can build all of that stuff that I built by hand. It can build it for you. And I'm going to skim a little bit because I am running out of time already. But macros can build everything that you need for something like this. And you can have an implementation that's this simple, where you just require send, and you don't have to do anything else other than include it in your class. There's a send activate that needs to be called to tell it, okay, go figure out all of the stuff you need to figure out to make it all work. And it'll just work. And I'm going to skip past this slide very quickly, but if you want to go look in more depth at how this works, you can pop over to the GitHub repo and you can dig into some kind of ugly macro code to kind of see how it actually works. But it's pretty cool and it works really surprisingly well and shockingly fast. It's shockingly fast. And you can do it in Crystal just using the power of macros. Now, one other thing that I'm going to skim through really quickly is method missing. Method missing is another one of those things that lets you do a lot of really dynamic stuff. And it's used a ton in Ruby to build dynamic stuff. In Crystal, it is a compile time macro. And what it does is if there's a method that's invoked and there's no method to answer it, the macro can be called. And the macro can do whatever you want. And so in this case, we have a class that does nothing but implement a method missing macro. And that macro, when it's called, will create a method for whatever was called that just prints out some diagnostic information. And so if we run this code, it looks something like this. You can see that we just intercepted the calls. And the thing about that, though, is that you can do some really interesting sort of wrapping and dynamic things with it. And so if we have this little sample class here, it's a little widget that just takes a value and implements a method. And we have a simple little proxy class that isn't much more complicated than the previous thing that I showed you, except it has a call to object send in here. Now, I wouldn't have to use send in here for something this simple. We could actually just substitute the call name in there and construct a direct method call. But for maybe more complicated wrappers, you would want to use send if you have some additional logic that's figuring out exactly what methods you really want to invoke. in here. And so I just put it in to illustrate that you can do this sort of thing. If we run it with code like this, boom, it works. We have a working proxy object that wraps our actual object, intercepts all the calls to it, and prints out some additional information. It's a pretty powerful thing, all wrapped up into just a few little simple uses of macros. And these examples really just scratch the surface of what you can do. I mean, it'd be really easy to talk all day in depth about the things that you can do with macros and how you can do them, and bad ways to use them and good ways to use them, and all that sort of thing. But we only have a half an hour. So I'm open for questions, and I am going to be uploading the slide deck plus all of the code that is in it to this repo, either later this evening or tomorrow. And so, later on, if you want to go dig into it, and when you have more time, feel free to drop by the repo and take a look.
Awesome. Thank you so much. Thank you. That was really cool. I'm super fast. I'm going to have to go check out that repo. I actually saw that repo, but did not dig into it.
Yep, there's nothing there now, so.
There will be. Surprisingly, no questions. But I guess I have a question for you, which is, sure, how do you handle failure cases in Send? Do you add nil to the types, or do you use other means to handle sends that might not exist?
So I'm trying to think of how I actually handle that in the library that I wrote.
Excuse me.
You know what? Want to go look?
Yeah.
Actually, I think right now what I'm doing is
I see a return nil.
Yeah,
that's for the question.
We rescue the key error and return nil. Well, actually, there's two. I have two different definitions of sends.
Yeah.
I have one with the question mark and one without. The one without will just throw a key error, because when it tries to look up the method, it'll throw the error that it can't find it. And if you put the question mark after it, it'll return nil.
This is an interesting trade-off from the type system to how do you handle sends that don't exist.
Yeah.
Yeah. All right. There are some more Q&As coming in, but unfortunately, we're going to move on to the next talk.
Yep.
I'm very, very sorry. People who are asking Q&As, you might be able to find Kirk in Discord.
Hit me on the Discord. Yep.
Very sorry, everyone. Okay. Kirk, thank you so much.